Now we are speaking about measuring tip of so-called MT device for positioning the ionization chamber into defined depth in water fountain when relative and absolute dosimetry are performed in radiotherapy. Here is the water tank. The semi-flex ionization chamber is already fixed on its holder. Now we need to put measuring device on ionization chamber. First of all, we place a piece of white plastic or paper strip to create white background to better see small scale tip of this device, and then we can put the MT device itself. After short waiting time needed to stop waves on the water surface, we move ionization chamber to so-called calibration position, when the line of MT device with its reflection is equidistant. It means you see the distance in between black marks are equal. The main task of this presentation is to show you that small movement of ionization chamber up or down from calibration point can be easily recognized by in short time experience human eye. Now I am moving by 0.1 mm the ionization chamber down, and you see that the B coordinate of the control pedal is increased by 0.1 mm. And what it happened? The line of MT device with its reflection is not equidistant anymore. After that, I am moving ionization chamber to opposite direction by 0.1 mm. And again, you see not equidistance of the MT device with its reflection. So we can do a conclusion. By this device, we are setting the ionization chamber with accuracy plus minus 0.1 mm. Basically, the idea of presented device is developed from petricipilar positioning device in which the control tip in calibration position should be in contact with water surface. And that was a disadvantage of this design due to presence of waves on water surface and adhesion of water with control tip. Now some words about advantages of here presented device. First advantage, device effectively means with measuring effect is using the MT reflection in water surface for increasing the positioning accuracy by twice, because movement of tip relatively to its reflection in water is faster by factor 2. Second advantage, device is placed into calibration point without contact with water surface. Interfering waves are excluded. And the last advantage, device is applied directly with the ionization chamber, which was previously fixed into chamber holder. Any intermediary part is excluded. Let us compare our device with similar devices of some known companies. True fixed attachment system of PTV Freiburg. Despite the lack of clear definition for calibration position, we quite precisely, plus minus 0.1 mm, can place the cone close to the water surface. Unfortunately, the main disadvantage of true fixed system is existence of this cone intermediary part, which cannot be produced very precisely, and it have to reduce the precision of all system up to plus minus 0.3 mm, as states in its manual. A large cylinder with crosshair for IBA company. The contact with water surface is main disadvantage of this device. Due to adhesion with water, you cannot precisely place the system to so-called calibration position. And precision of this device we estimate as plus minus 0.25 mm. Here I schematically show possible variation of design for MT device. 3 examples on left hand are desired for large depths in water. Design with float petricipilar, design with sinter microtensioner, design with part of medical needle for plate parallelization chamber. The flattened copper wire is good material for making these examples. 2 examples on the right hand are desired for small depths in water, designed for electron chamber and designed for Farmer of semi-flex chamber. It was mentioned at the beginning of this presentation. The fluoroscopic film is a good material for making these examples. And I will show you how easy to make presented device in every radiotherapy department without any special instruments. You need piece of fluoroscopic film, scissors, and precise caliper. First step is to cut off a strip of 1 millimeter width. It is not so easy, but after some attempts, if you are lucky, you will get a strip of exactly 1 millimeter width. Then you will prepare a holder for this strip as well made of fluoroscopic film. First of all, you need to cut two holes in fluoroscopic films, one for plumb wire and second for ionization chamber, and then to cut off the holder itself. Then we use 1 millimeter strip for making our measuring tip. It doesn't matter how long it is, 6 or 7 millimeters. Later we will measure its length precisely by caliper. The measuring tip for great depths is better made of copper wire. Firstly, you should flatten wire, then to cut off 1 millimeter strip, and finally to cut the required length. The measuring tip made of copper is easy to adjust. At the end, you need to draw scaling marks on the strip, and your device is ready. Here is presented MT device calibration certificate for our PTV semi-flex chamber when length of measuring tip is 6.2 mm. As you see, you should take into account the radius of chamber 3.41 mm and shift of everything point 1.7 mm. So, when MT device is placed to calibration position, the effective point of this ionization chamber is located on 8.41 mm depth in water. Conclusions. The MT device demonstrates excellent precision in positioning ionization chamber into defined depths in water, and we invite medical physicists to use this device in their practice. If you find that the presented device is useful and you would like to support new interesting project with the name MT device in brachytherapy, you can financially support future projects. As well, you can ask questions and arrange a training visit to our hospital by email.